Number 20 gives us a contingency table, and we're trying to find some probabilities. So for part A, it asks what's the probability of unarmed. So we're just looking for, out of everyone, since we're not limiting it to anyone, there's nothing given to us, out of all 1424, how many of them were unarmed? Well, looking at the unarmed category, we see there's 128. So 128 out of everyone, 1424. Next, we see for letter B, what's the probability of unarmed again? But this time, they're giving us that it's someone who is white. So we have probability of unarmed given white. So since this is what's given, then it's only out of those people. So we can ignore everyone else. No one else matters here. We're only looking at these people here since we know it's someone who's white. And out of those 732, how many of them were unarmed? Well, we see there are 50 of them. So this would just be 50 out of 732. So notice when something's given, that changes our denominator. Letter C says, what's the probability of unarmed and, Hispanic and unarmed? So in this case, let's erase all this. In this case, again, nothing is given to us, right? It's just out of everyone. There are 1424 in this group. And out of them, how many are both Hispanic and unarmed? Well, we have Hispanic are these people, and unarmed are these people. And the only people that are in both is the one where they cross. So there are 23 that are both Hispanic and unarmed. So we can just say there's 23. Now, if you wanted to, you could have also used the multiplication rule because it is an and probability. But you'll see it really just gives us the same thing. It's just extra work. But let's just do that really quick in case you are wondering why we didn't multiply in this case. If we wanted to, the multiplication rule says that this is equivalent to probability of the first thing times the probability of the second thing given the first thing. So it makes it more complicated, but let's see what happens here. I can do what's the probability of Hispanic, and this would be 251 out of everyone. And then we have times the probability that they're unarmed given Hispanic. So it's only out of the Hispanic people, what's the probability that they were unarmed, which is 23. So we have 23 out of those 251. And what we find is those 251s just end up canceling out and we get the same answer. So we didn't have to go through all that extra work. If you can just understand what the and means, it means they're in both categories, which are those 23 people. Finally, we have armed or other. So if we're looking at armed or other, there's lots of ways of doing this, but the easiest way is probably the addition rule. And if you recall what the addition rule tells us, it's the probability of the first plus the probability of the second. But because of when we put those together, there's some overlap, specifically armed and other. There's 55 people that are in both groups. We have to not double count them, so we subtract them off. Probability of armed and other. So if we put this together, this would be probability of armed is 1242 out of 1424. And then plus the probability of other, which was 61. But then minus the 55 that got counted in both groups. And this would give us our answer of 1248 out of the 1424. Finally, for letter E, it's asking us, are being shot while unarmed independent events? So let's remember what it means to be independent if we wanted to show this mathematically. It means the probability of one thing stays the same, right? If we want to find the probability of A, it's still the probability of A, even if we know something about the other event, given B. Well, if you notice, part A and B, they already helped us find the probability of unarmed and probability of unarmed given white. And let's just turn these into decimals so that way we can compare them a little bit easier. This one right here is 0.0899, and this one is 0.0683. And we see, are those probabilities the same? No, they're not. In fact, the probability of someone being unarmed when they're shot while unarmed, when they're white, actually drops. It goes from almost 9% to just under 7%. So this is, since it actually changes the probability, what we say is the probabilities are not independent, they are dependent. And we can just compare those two things. The probability of unarmed does not stay the same when we're given the information that they're white. And if you think about it, it's like saying, well, what's the probability of someone being shot if they're unarmed? Well, it depends. Do we know if they're white? Because if we know they're white, it changes the probability. So it's dependent.